So you can do a lot of application problems with proportions. This one is something to do with a scale drawing. So you've got two different kinds of measurements going on here. The 1/2 inch is on the piece of paper, on the blueprint, on the diagram, and the 10 feet is in reality. So I want you to think of the fact that you've got two things going on here. You've got measurements on a piece of paper, and you've got measurements out there in the construction site. So we're going to set up a proportion. It's important to get it set up correctly. So for this one, I think I'm going to decide to do the paper dimension on the top and the real number on the bottom. So let's pick this first pair. 1/2 inch on the paper works out to be 10 feet in reality. You put down your equals mark, you come up over here and get another proportion. So 2.5 inches, notice that's on the paper, and I'm keeping it on the top in the same location as the 1/2 inch. And I'm trying to figure out how many feet does that represent in reality. That's one way to set it up. There are actually 4 ways to set this up. If somebody did the reciprocal of this, that would be correct as well. So just because yours may not look exactly like the example doesn't mean it's incorrect. All right, so let me come down here. Here's the proportion that we're going to work with. So let me scroll on down. And you can see the inches on top and feet on the bottom. The LCD is pretty simple to figure out. We've got a 10 and an X, so we just multiply those two together. So here I go with my process. We could actually simplify that number down right there too. And if you see that, it's okay to go ahead and simplify things to make your work a little easier. So I'm coming back through here, multiplying each side by the LCD. Looking for that cancellation. That's why we did it, so we clear the fractions out. And then doing the arithmetic. So careful here, I've got an X in there that I did not cancel out. Sometimes it's easy to lose sight of those. Then I'm going to multiply 2.5 times 10. And I'm going to divide each side by 1/2. You can type that in your calculator if you're not comfortable with fraction work. This is going to be 50 feet because this is the number that's in reality. This is the number that's out there in the construction site of the house. And I think I can skip over that. This is where I want to show you all these other ways that you can set it up. So you've got inches over on the top and over feet here. You can put the feet on the top and the inches on the bottom. You can actually compare inches to inches and feet to feet. And then this is the reciprocal version out here. It's just important that you keep things matched up as you work, corresponding. So as we're talking about corresponding, let's do a quick geometry and then we'll stop on these proportions. Similar triangles, there's a symbol here that is sort of a wavy line there in the middle. Tells you that the two triangles are similar. What does that mean? That means that the corresponding sides, you can Google that, I guess, are proportional, or they're in some sort of ratio to each other. So let's take a quick look. This side AC corresponds to the similar triangle PR. So the sides are not the same length, but they are proportional to each other. And then if we look at another pair of sides, this side BA corresponds and is proportional to the side QR. Also turns out that this angle here and here are the same. So similar triangles have corresponding angles that are equal to each other. And the last correspondence that I see is down here. This side AB corresponds over here in the larger similar triangle to the side PQ. And again, you know, if we looked at these angles, we would see congruency or the same measures on the angle measures. So we're going to try and set up here and solve for this letter X. And I think, again, I've got lots of ways I can set this up. I think what I'll do is correspond from the small triangle to the large triangle. So I'm going to put 6 over X for the first ratio. And then I'm going to correspond again, keep it in the same order, small to large. So I'm going to put the X minus 4 on top and the 10 on the bottom. So pick up corresponding 6 over X, keep the same order, X minus 4 over 10. LCD, I hope you can see, is 10X. Bracket everything. And insert, so we can clear out fractions, the multiplier of the LCD. So it looks like a 60 there. I'm going to scroll up. Whoops. I think I need to get down here where I can have a little more space. Don't lose the fact that there's an X right there. I'm about to lose him. Let me write that down up there, and then I'm going to bring all this down here where I have a little more space. All right, so once I was working along, I ended up down here with a line that reads 60 equals X times X minus 4. The reason I wanted to show you this one is to do a little review here. When we distribute this X, you get a second degree equation. And the way you solve second degree equations is you set everything equal to 0. So I'm moving the 60 across to the other side, subtracting it. And then you factor when you can. And I think this is 10 and 6. That should do it. Yep, that'll multiply and give me 60. And if I put the negative on the 10 and the positive on the 6, so what do you do next? Well, you take each of these factors and set equal to 0, because when you hit this second degree line here, that told you you were going to be expecting 2 answers. So I've come up with 2 solutions here, a positive 10 and a negative 6. Let's go back and think about what I was looking for. I was looking for the length of a side. So can the length of a side be positive 10? Yes. And that would make this side 10 subtract 4 or 6. Can the length of a side be negative 6? Nope, you can't measure the side of a triangle and get negative 6. So on this one, sorry, I don't want me to make you seasick there. On this one, we have to reject this answer because it doesn't fit the problem. So we were expecting 2 solutions and we ended up with only 1 solution. Okay, I think that's a good place to stop with proportions.